Hello, this is Deborah Barrett with the Cincinnati State Physics Department introducing momentum. This is the first of a series of videos explaining momentum and relationships that relate to momentum. I think of momentum as being inertia of motion. You know that inertia is the inherent tendency of matter to maintain constant velocity, whether that's a constant zero velocity or a constant non-zero velocity. Momentum refers strictly to cases where that velocity is non-zero. And as you see, the symbol for momentum is P, with momentum being defined officially as the product of mass and velocity. Please notice this is not just a speed here. This is v velocity, which is why I put the arrow over top of it, like your textbook does, to incorporate directionality. Since momentum has mass times full-fledged velocity, that means momentum has the same direction as the velocity of the object, which means that momentum is a vector, just like velocity is a vector. Direction is a crucial part of the meaning of momentum. Momentum, as you can see from the formula, depends to some extent on the size of both of these factors. If you have an object with a large mass, such as a cruise ship, it can have a great big momentum even if it has a pretty small velocity. That's why you don't want to be in your rowboat in front of a cruise ship hoping that the ship will turn and not run you down. That's not going to be a good plan. In contrast to that, you can consider an object with a very small mass but a very large velocity, and that will still have a big momentum. The classic example is a bullet. You don't want to be in front of a bullet and hoping to brush it aside, well, unless you're Superman, because a bullet has a very high momentum. You also have a large momentum if you have a pretty good size mass and a pretty good size velocity, like a car on a highway, which is why you're not supposed to walk on a highway. You have the combination of the two that predicts your momentum. That means you can also kind of think of momentum as how hard it is to change the motion of your object. The more momentum something has, the greater its tendency to maintain that non-zero velocity, and the harder it is to change its motion. This concludes the first part of the momentum video series. Please go on to view the second video, where we will talk about conservation of momentum.